Okay, what's going on, guys? We have another tutorial of a question physics, and this one is very special. Make sure, guys, you read all the information and all the graphics that they give us here. They didn't give any information about the graphics. Even if you see the question, you have to make sure that the information has to do with the graphics that they give us has to do with the question. So I tried to do this question the way that I'm usually do, but I keep missing some answers. But now I found out that this graphics here, the two graphics that you guys see, the two graphics that you guys see in this section has to do with number 39. Okay, and sometimes they make these mistakes for not it's not obvious for this, because usually they will say there's a figure that you can relate this problem. But anyways, so I will do this problem and then we'll carry on for the next, just to make sure that the information that you have is important. So we have a loop. I'm gonna write down the information. We have the diameter of the loop is 0.04 meter, and we have the diameter of the solenoid, and that's 0.02 meter. The loop has a resistance of 0.1 resistance, and the solenoid has a length of 0.1 meter and 100 turns. So now they're asking me what is the induced current in the time, when time is 0.5 second. When you see the graph 0.5 seconds, it's kind of in the middle between, it is in the middle of 0 and 1 second. And if you do the differential, the current differential between the two points, it's going to give us a current of 0 amp. If you do the differential between the 2 points, it's kind of logical. This question number B. Now you see in the graph, it goes from when the time is 1.5. So when time is 1.5 seconds, the current, it goes from 20 amp till 0 amp. So it means that there is a differential current in this section. And now we have to find induced currents in 1.5. Okay, so I'm going to use the EMF formula, and that's number of turn multiplied by the area of the loop multiplied by the magnetic field, okay, divided by the differential of time. So EMF is equal 100 multiplied by the area of the loop, that's 0.02 square, multiplied by the magnetic field of the solenoid, so that's 20, the differential, 20 amp, divided by 2 pi, and the radius of the loop, that's 0 square, 0.0, my god, let's do it again, hold on, delete, so that's 2 pi, 0.02 square, and everything is divided by differential of time, and that's 1.5. Okay, so the EMF in this section will give us 1.6 times 10 minus power of minus 5 volt. From here, to find the current that goes into the loop, it's going to be the 1.6 times 10 minus 5 volt divided by the differential, or the resistance, and that's 0.1. So the current the induced current in the loop is going to be equal to 1.6 times 10 minus 4 amp. Question number C. So the differential in the solenoid is steady, and it's actually 0. So the current of the solenoid is 0. And if you use it on the hello. Not too bad. Give me a second, okay? And this one, if you replace this one to find the currents in the loop, will give you an EMF of 0. So the current will be 0 in the loop.